Hello everyone and welcome to this presentation. Today I, Jatin and my teammate Sarvesh Patki are here to present our IoT project for this quarter. We are working on an adaptive IoT communication system called SwiftNet. For this project, we have developed a system that includes 6 ESPs, a Raspberry Pi, 7-segment display, an LED matrix, a push button, and an LED ring. Currently, only one ESP is connected to the system. We can see on the screen that only ESP139 is active. When we run the Python code on the Raspberry Pi, we can see that ESP139 is actively transmitting the data. Over here, we can see the transmitted data from ESP139. This is also confirmed on the 7-segment display, which shows the number 1. Additionally, the LED ring lights up, indicating that ESP139 has become the master of the swarm. For the next phase, we'll be adding the other remaining ESPs and we'll wait for them to join the swarm as well. Now, we will connect the second ESP to our system and we'll wait for it to join the swarm. After a brief wait, we should see that it successfully joins the swarm. And yes, now the second ESP has joined the swarm. Here's something interesting. The number of LEDs lighting up on the LED ring changes dynamically based on the brightness detected by the photosensor. At this point, the Raspberry Pi can confirm that two ESPs that we have connected are sending the data. Now, in order to save time, we'll connect all 4 ESPs together and we have connected the 6 ESPs together and now we'll wait for them to join the swarm. After a short synchronization period, all 6 ESPs successfully join. The Raspberry Pi can also confirm this by receiving data from all the 6 ESPs, which is also displayed on the 7-segment display. To demonstrate the dynamic master selection, we use a torch to alter the photosensor values for the different ESPs. For example, when we shine the torch on one ESP, the 7-segment display shows 234, making it the master. Shifting the torch to another ESP changes the master to 147. The system automatically adjusts based on the brightness level detected by the photosensor. The IP address of the master ESP is also updated accordingly. Now, let's look at the LED matrix, which provides the visual representation of the brightness data collected by the photosensors. Here's how the LED matrix works. Each column on the matrix corresponds to an average brightness value captured over a 4-second interval. The brightness values are calculated dynamically, providing real-time insights into the sensor readings. After 30 seconds, the matrix completes one cycle and resets. It begins again from the first column, ensuring the display remains consistent and uncluttered. The number of LEDs lit up in each column is proportional to the brightness intensity detected by the photosensors.
Hello, this is Sarvesh, and I'll be explaining to you how our project analyzes these logs and processes them. So this is a raw data that is sent to the server by each of the ESPs, and our server processes them and figures out which one's the master device and things like that. So this is the dashboard that we have created using React JS. You can upload your log files to it, and you can see how many times which device is selected as the master and how many events they send and the average duration that it takes for them to send those events. And this graph shows the device values over time. So how many events over time are sent by each of those 6 ESP devices that we have in our system. And this is the duration analysis of the entire system. So how many events are sent at each unit of time. Both these graphs help us analyze the latency of the system, which we can use to benchmark against the cloud dependent solutions which are currently used in IoT.